Hello, welcome to shop. Today we're going to continue on with this project. In the last video we loosely established our wiring, we tested out diodes, we got things kind of set in place, so we're now ready to get everything mounted in this box. Let's get into it. Okay, we're back. So I started getting some stuff roughed in here. We're just going to keep going. I think what I'm going to do is mount this stuff on plastic fasteners, which I don't have currently, so that's okay, but I think I'm just going to temporarily mount them with stainless fasteners and put tape over them. The reason for that is this is two different points of potential here, and this is a third. So if I was to push this thing down on a metal surface and the bolt heads touch something, we could potentially create a short circuit. So that's not very good. But I think that's our way around it. I did order some plastic fasteners, and we'll just temporarily mount it with stainless and change it out moving forward. But we have our low voltage shutdown circuit mounted here. I may also make this stain or plastic. I haven't decided yet. I gotta mount this one over here in this corner, but you kind of get the idea of what we're going for. And then I can kind of start to clean the wiring up in this thing a little bit, because I left all the wiring a little long because I didn't know how I was going to do it all, and it's a bit of a hot mess. So we just got to start getting some stuff mounted so we can start shortening stuff up and getting it final and where it needs to be. So we're just going to keep on keeping on. You can see we got this battery inlet here wired into the low voltage shutdown circuit already, which is great. And this, once we mount it, will be wiring into the low voltage shutdown circuit, so that'll be good. And I haven't decided yet, but I might actually make a top for this and inset the power supply in the top. I don't know yet. Okay, so if editing went well, you just watched a loose montage of us building most of this. Now what we're going to do is we're going to just test this to make sure it's still working properly and that we can clip our batteries on. This is a battery with 2 bars. Just put that right on there. And we've got signs of life already. Now I do think I'm going to add a breaker onto here so we protect the battery. So I think that's going to go right here and right here. But we're still in mock-up mode right now, so that's okay. We cleaned up some of the wiring. There's still some mess going on here, but I just kind of wanted to see. Yeah, I think this will work out. So let's not let that get too low. There's aluminum there. This is screwed down all the way, our voltage increaser. I do want it up on spacers ultimately, but for now we have it just screwed down all the way for the mock-up, and that's okay. This is just a mock-up, so you can get away with stuff like that. But let's go into voltage set. And let's go over here. And let's just see if we get our 60 volts. Looks like she's putting out power. That's what we want. Now you can see we have only one of our low voltage shutdowns is operational. The other one doesn't have any reverse current on it, and it doesn't have any power coming out. So that's exactly what I wanted. I wanted to be able to run it on one battery or two, which is what we got going here. So I think everything's right on. So now I got to decide, am I going to make an aluminum top for this, or what am I going to do here? Okay, so in typical design as you build fashion, I do have some 30 amp breakers available to me. Now this power supply puts out 20 amps, and I know there's going to be loss in all of this stuff. These relays are rated for at least 20, maybe a little bit more. So if anything's going to fail, it's going to be the relay and the low voltage shutdown. I'm sure we could push that a little bit. Mainly I want this for short circuit protection anyway, to protect our battery, so it will do that very well. The other thing that I was thinking about that I'd like to add is an on-off switch. Now I have a bunch of these cheapy toggle switches, but they're only rated for 15 amps. I don't know if you can see that there. There you go. Rated for 15 amps. But they are 2-pole, so if we wire these in parallel, we can turn this into a 30 amp rated switch. So I think that's what we're going to do. We're going to mount that close to the switch closest to the battery, so we have battery isolation. Just in case I want to take this somewhere, I don't want it on the entire time. I can clip the batteries on it, take it somewhere, and turn it on when I get there. So we're going to do this twice. I have 2 of everything. I have 2 breakers and I have 2 switches. So we'll mount a switch over on this side and a breaker over on this side, and then the same thing over here. So I think that will work. That will protect everything. I'm putting the switch closest to the battery only because it sticks out further. That's the only reason why I'm doing that. The breaker's reset button doesn't stick out as far. I figure less things will get hit if the switch is closer to the battery. I normally like putting flush mounted switches in projects like this, but we're at run what you brung stage, so that's what I got. That's what we're going to put in. I think it'll be okay, because it'll be right here at the battery anyway. It'll be alright. So that's the change that we have there, and I'm still undecided. I think I am going to make an aluminum cover for this, but I'm not there yet. Okay, so I think I'm settled on a layout here. We're going to go with something like this, 9/16 for center off of our battery mount, and then we're going to go 1.5 inches for center for our breaker. I think that'll work out reasonably well. The covers are going to be a little close together. I might bump that breaker over just a hair more, but I do want them kind of tight with each other. So I think we're going to rock with that. Get our pilot holes drilled. And I always do like using tape to lay out things, because then if I mess up, which happens, I can just take it off. So pilot hole and pilot hole. Just like that. Now these are going to be 2 different sizes. The switch, I think, is 15/32, and the breaker is going to be 7/16. So we're going to have to swap out from our fancy 3/8 old school drill. Have to swap out from that and go to our fancy 1/2 inch old school drill, all running on M14. So we have our drill bit for our switch. Now this is going to be a grabby bastard. Watch me launch everything across here. There we go. Got that in. And then take that drill bit out. Put the one in for our breaker. Same thing, launch, grabby. There we go. Nice and easy. These cheap Harbor Freight bits are good for drilling plastic and aluminum. So I had an old set that I was using for metal and everything, and I decided I got a set on clearance. I just use them for plastic and aluminum now, and they stay pretty sharp that way. So now we can take this off. You can see we got a little bit of burrs going on there, but we can get rid of that. One nice way of doing that is using one of these deburring tools, and they work great on softer things like this plastic and aluminum stuff. So let's see how this looks. Now, we're just going to test fit the switch. We're just going to test fit this because if you notice, the screw terminals, I won't be able to access them anymore. So just a temporary mount on that. The breaker we can go for. Let's just see what we got. So there is our switch. It's a nice fit. That'll work out well. Let's see what we got going on here. This is a little bit thicker, so I'm going to take the spacer washer off. I think that'll work. And I'll just temporarily put this on like I said so you guys get the idea. I know you can't see anything, bear with me. Now, this isn't really keyed or anything like that, so we'll have to make sure that's properly tightened so it doesn't spin around. Ideally you would have the stuff somewhat keyed, and then it won't spin around on you, but it's okay. We will be alright. Now the breaker we would be able to crank on, but I might just remove it again anyway. So we'll just do finger tight on both of these. Okay, so let's close that back up. Maybe. And this is what we're going to end up with. We're going to end up with a switch and a breaker. So the breaker is nice and slim. The switch is along the profile of the battery mount. You can see there it doesn't stick out much further. So I'm optimistic that it won't take too hard of a pounding in that location. One never knows though when you mount stuff like that to the outside of a case. But what I do want is to be able to have a battery on this. Just be careful I don't put it on all the way. I want to be able to have a battery on it and walk around with it. So I want to be able to have it off so the battery can be on. Alright, so we're going to go and lather, rinse, repeat, do this again on the other side. Okay, we're back. So what we've done here is we've got our switches wired in, we've got our breakers wired in, we've got our two positive diodes wired in and our two negative diodes wired in. We've got our voltage DC to DC converter for voltage increase up to 60 volts from the nominal 20 from the batteries. This is temporarily mounted here. I want longer studs for it, so that's just temporarily in place for testing purposes. We can make it a little bit nicer later. We've got the wiring mostly finished. So to recap how this works, we're going to have DC in through our batteries. That's going to then go through the breakers, which goes through the switch, so we can isolate these on and off. And then from the switch, they independently go through the low voltage shut off. There's two of them. They're underneath that cluster of wires. And then we'll go through our isolator diodes for the positive. Then the negatives come from the battery through the low voltage shut off through the isolators for the negative. These are isolator diodes for that. This ties directly to our voltage increaser, as does the load side of these two diodes. That goes directly to the voltage increaser, and out of the voltage increaser we go directly to our power supply, which is now mounted in a nice aluminum plate that is going to mount just like this. So the next step we have here is going to be, we have some aluminum that we cut, and what I like to do is set that it's just flush. This is a scrap piece of that same aluminum that the power supply is mounted in, and what we can do is we can clamp that just like that, and drill a hole and get that mounted to our box, and then we'll do the same thing with another piece of aluminum that I've notched for the vent, and we can mount this one right here, and that'll give us the advantage of being able to set the elevation for this and everything. And then what we'll do is set this on top here, and we'll use some riv nuts to fasten everything together here. These will just through bolt to the plastic casement, but the top here we'll use riv nuts because this is very, very thin. You can see how thin that is. So we'll just set some riv nuts in that and get that so that we can take the screws in and out without really damaging anything. And that gets us our rough-in stage here, and we'll pretty much be done until we get some fasteners, plastic fasteners, so we can isolate these diodes and everything else. So making progress here. Let me get this clamped up, get these mounted in, and we'll be back. Okay, so we did a lot of the boring, hole drilling and everything else, but we have the nut certs left yet. So all I did was I drilled holes, pilot holes through everything to get our fasteners in, and this is what's going to hold this whole thing together. Let's just pull that out, and you can see we have pilot holes in all of our angle here now. So now we can get the right size drill bit for the nut certs, drill that out, set the nut certs, wire this bad boy in, and I think we're actually going to have everything complete. Okay, so first step is to drill the hole. Now I actually have aluminum nut certs here, or riv nuts, whatever you want to call them. So I'm going to try these out. I've not used them yet, so it'd be interesting to figure out if they're worthwhile or not. Maybe they suck. I don't know, we'll find out. But this takes a 17/64 drill bit, which is what we have in our custom M14 adapted old school Milwaukee drill, and we're just going to drill all these out to 17/64. There we go. I just wasn't holding on to it strong. Okay, so now we got our holes. Next up, we need to get our set tool. Let me get all the metal shavings out of this first, and then we'll get our set tool and we'll set everything. Get our dust out. We're going to use our super blower. Okay, so riv nut tool is pretty simple. It's just a mandrel that is pulled with a lever arm. So you have these huge handles that you pull. Now with something like 832, you really don't need a lot of leverage, so be careful. If you have these smaller ones, you can overdo it. Ask me how I know. So here we go, we have one here. We just squeeze the handle. And we'll see how it's set. I think we could get a little bit more on it. I don't want to go overboard because it is aluminum also. I think I want to stop there. Let's see how that's set. See how it looks. Screw this back out. Okay, we don't have a whole bunch of aluminum in our set tools threads. Everything came out okay. Now one thing I did notice with these is they don't always set perfectly centered, which you can see here. Sometimes when they pull and they finish off center. Maybe it's something in how I'm doing it. Maybe it's just how they are. I haven't done a ton of these things to tell you one way or the other. Let's do our next one here. Now I went a little quicker that time. We'll see if it's just as off center. And all we'll do with that is we'll just compensate the cover if we have to. Yeah, that seems to be, I mean, it's set. It's just what they seem to do. Get the ones closer to me now. Maybe that'll make a little bit of a difference in how it installs. I was reaching out pretty good there. I don't know. Let's see. So there we go. And we'll just give it a little bit more. Seems like they're all kind of the same. But you can see this is pretty quick and easy. Yeah, none of them are centered up. Which, whatever, it's fine. This is just a little home shop project anyway. It's not like it's a mass production run or anything like that. I don't think I can go tighter at this point. So we set that, give it a little bit, set it again, take it out. Now, since I drilled exactly the size hole I needed in our plate, we'll see if any of these actually line up before we wire it in. Looks like they might all work. If not, we'll get something that works. Now, truth be told, this isn't set exactly perfect. If I notice this, it's a snug fit, but if I notice this coming out, I might just give her some hot glue snot. Maybe we'll do that anyway, just because I haven't played with that a whole lot. I think we're good to wire this in, and all we have on this is our temp sensor, which is this, and that just plugs in to our temp sensor port here. I just unplugged it to make life easier. So there's that. And then we have our positive and negative THHNs here, which the positive, let me flip this over so you can actually see. Positive is this one, sitting in like so. I can tighten this up, try and hold it straight. Actually, I don't know if I care if it's straight or not. And then this one, get this one the other way so they can't accidentally get into each other. And looking at how close that positive is to that, I think I am going to try and force that to sit just like that. So now that will be exactly what we want. Yeah, that's kind of already fallen out, and if this box falls over or something like that, it'll definitely probably pop that out. So let me get some hot glue. We'll see if we can put this in. Okay, so I'm new to the world of hot glue, but we have a M18 hot glue gun here, and we'll just slather some of this on here and see if it makes a difference. I honestly don't know. I guess it's kind of like welding, but with glue. I'm just going to do the two sides and not like all the way around it, because all I really want is something that sort of gives it some stiction, and I think we'll get that with this. Now, this stuff is kind of gooey, stringy, as it were. It seems to be working okay. I think I can live with that. So this thing is going to continue to ooze, so I'm going to put it off screen. But we did turn it up to 220. We gave it all the beans, which seemed to be the best idea. Hopefully that is true. Turn that off, stick it off screen. I think that was successful, actually. So let's see how that's sitting in there. Sitting nice and flush. And that should cool down and give us a good enough seal. And we'll put this back in like that. Start a fastener. We might have problems with fasteners, we'll see. Start another fastener. Start that one. Start that one. Let me get these set and I'll be right back. Okay, here we go. It's in. It's snug. Seems like it's attached. And it's the moment I've all been waiting for. We have two M18 batteries. They're both 5.0s. Both should have a decent charge. Let's get some of the crap out of the way here. Here we go. Slide that on. Nothing should happen yet. Slide that one on. Now, when we turn on one of these switches, turn this one on, we should get our power supply to flash up, which it did. We should be able to turn that off, and it should shut down. And it does. And I should be able to turn this one on over here, and it flashes up again. And we should also be able to run with both. So now neither battery is trying to backfeed the other battery. We have breaker protection. We have isolation switches. We have low voltage control underneath here. We have an isolation diode here and here. We have our voltage increaser here to get our 60 volts that this supply could put out. Now, truth being told, I'm probably only going to mostly use this for testing tools, but I thought this would be, hey, it's a fun little project. So let's get our Fluke 223 fired up here. And the nice thing about the 223 is I can set it so that you can read it. And we can put our probes in here. Move that. Actually, I bet you this has the pin through it. Maybe not. No, this one does not have the pin through it, so this is just a banana. Never mind. Okay, so let's turn on our supply. 5 volts right away. Let's do our voltage set. We'll go to course voltage 6, 7, 8, 9. I'll just run it up to 24. 24 volts. And we'll run it up to 36. 36 volts. 48. 48 volts. And all the way up to 60. Okay, so 61 is about what we get out of it. So that's sweet. We have ability to control all that. So if we set this at 20 and we go to our current set, now we're currently limited to 24 amps, which is pretty good. I need to make up a more robust pair of banana jacks, but what we should be able to do is use the cheapy ones I have, and let's just see if we can get a better test on our super blower. If you recall, I wasn't able to run the super blower at full speed with our other supply because we ran out of current. So let me play around here and get all this set, and I'll be right back. Okay, we're back. We got the blower set up, and as you recall, if you watched that video, if you didn't, take a look up here. It's the super blower. Got the name because of the amazing graphic it has of the dog being turned into a superhero. When we tested this before, we got 13.2 volt shutoff. So let's see what we have now. So you can already see we're drawing more than 5 amps. So on the low setting, we're 0.64. Find the button here. Low middle setting is 2.2. 5.4. 8.0-ish. And what I like to do, since we have a good current draw, is let me get a little bit better on my so you can hear it slowing down as I decrease the voltage. And around 13.6 we lose it. Let's turn the supply off. So that's actually really low for an M18 battery. And I think what's partially going on there is in other parts of the world, these M14 batteries are much more prevalent. And 13.6, 13.2 is actually a safe cutoff voltage for the M14. So I think that's why they have that. And just to test the theory, I'd be willing to bet that we could probably hook this M14 battery right up to this and it would work. So I think that's why some of these knockoff tools are going to have a lower voltage, because of the M14 battery. We'll see moving on. I have other knockoff tools to test. This was a big part of the puzzle to test those tools, and now we've got that set up. So stick around, check the channel out in the future. We'll have more tests on knockoff tools like the super blower, and we'll just see how they work, what voltages they cut off at, if they're good for your batteries, or if you need to be careful with them. So I hope this project was interesting. It's all basically parts that I bought and assembled into something other than what it's supposed to be, but that's kind of how we roll. So as always, thanks for watching, and have a great day.